This is James Callan from UCL, presenting my and Justyna Petke's paper on optimizing SQL using GI. SQL is the language we use to interact with relational databases. We choose to apply GI to read-only queries, select queries in SQL. This avoids any risk to the database being accessed. We specifically target join statements. They select entries from different tables with some matching value, discarding those with no match. We propose 3 mutation operators for join statements. Our first mutation operator simply reorders join statements. Ideally, we want the statements which discard the most entries first, so later queries have to check less entries, which saves time. There are join statements which aren't needed, so we propose the remove join operator. We can see a real commit, which simply removes a join. The program did not need to change, despite the different results that the query will return. There are 4 types of join. Some joins discard rows with no matches, others don't. If we can change the join type and get smaller results, the transmission of these results will be faster, and therefore the query will be faster. What challenges are there? Testing is the main challenge. This GI should be applied to well-tested regions of code, which exercise the results of queries, testing the queries in context rather than directly. We must test queries on representative databases. Since databases change over time, testing snapshots from various time periods would be useful for finding changes which generalize. These changes may also impair some properties. Bigger results will increase memory and network usage. Therefore, a multi-objective approach would be suitable to find the best trade-off between these properties. In conclusion, SQL queries offer opportunity for optimization. We have proposed 3 simple transformations to join statements which could achieve this. Finally, test the program, not the query. Different results aren't necessarily wrong, but may be faster. Thank you for listening.
Hey everyone, that was a short presentation about optimizing SQL queries. For people who don't know, the short talks take this format where it's the present for a very short 2-minute lightning presentation followed by this Q&A discussion type format. Same rules as before. You will ask questions in the chat and I'll relay them and we can get some sort of form of discussion going. So Bill Langdon asks, how does it compare to optimized SQL?
Kind of, what exactly do you mean by optimized SQL? Because
do you mean hand optimized, Bill, or is there some sort of thing out there called optimized SQL?
Yeah, I'm not familiar with that. If there is, I think on the SQL servers, often there are optimizations in place. So like in the talk we mentioned the join order optimization, which is kind of a standard thing that is done in the servers, but that has to be done at runtime. And also it can go wrong because they don't have the same amount of time that we have to find the optimal order because we're doing it before we run the program. Also, those optimizations are trying to get exactly the same results out. So they take one query and want the exact same query out. We're not too concerned with having the exact same input and output. I think that this kind of optimization is going to be the most useful kind of when developers have kind of like over approximated the data that they're going to need for the application. So they've got a lot of different rows from the table or columns from the table, sorry, that just aren't necessary for the application to run. Maybe they thought at one point that it would be useful, but now they didn't actually use it. So it's just wasting time essentially.
So Myra has a comment, which I think you can maybe follow up on, that she thinks the correctness may be biased towards the data. Hence, this would change. Hence, maybe this would need to happen continually when the data changes.
Yeah, I completely agree with that. I think as well, when you do initially set it up, you could kind of take like snapshots of the database from various points in time to try and like generalize to different versions of the database as well.
Alexander basically asked, shouldn't GP be more adaptive and more suitable for this problem? Queries are short and therefore reasoning on a line may be coarse. GP operates at the level of a node. So did you consider GP for this problem?
I didn't really, because kind of when I came up with this this use of GI, it was looking at changes that developers had actually made. So they did already have the existing queries that they had rewritten to make more efficient. And I think like a lot of the queries where this is going to be most applicable are going to be quite long and complex queries. So I think that it's going to be hard for one thing, to kind of specify them in a way that GB could generate, maybe.
Well, I mean, the language has a syntax that you can read as an abstract syntax tree, and then you can modify from there. Do you think that's possible? Do you see advantages or disadvantages to that?
Yeah, I think it could be done like that. I think this is just kind of the first step, really. So to keep it in a way where we're pretty sure we can find these positive changes, and these kind of based on what I've seen in actual changes by developers. But I think it could be extended to different representations and different mutations that could be more effective in the long run.
Cool. So Wes Weimer asks, do you think the fitness function for SQL on a smaller test table is more or less vulnerable to overfitting than a non-SQL GI based on tests?
Well, I think this kind of GI would also still be based on the tests and kind of how the data is used within the program that you're changing. But yeah, I think maybe on really small tables that could be an issue. But again, I think that this is going to be the most useful on big queries on quite big tables, because that's when you're going to have the most issues with performance. Because if it's quite a small table, then I don't think it's likely that you're going to be able to get much benefit from optimizing the queries.
So you think there is an overfitting problem here?
I think there potentially could be. I think what you want is a query that is used quite widely throughout a program would be ideal. So then you're not really just testing the query so much, you're testing how it's utilized.
So Giovanni, I don't know enough about SQL to fully understand this question, but Giovanni asks, do you think swapping joins with wheres would work?
That's quite an interesting point. I think I'd need to think about that more. I'm not sure if how complicated that would be to do. In some cases, maybe it would work, and maybe that would be beneficial. But although joins are kind of like conditions that spread across multiple tables, I'm not really sure how easy that would be to do with where statements. But it's definitely something that I'll take a note of, and I think I should look into.
Wes Weimer has a question, discussion, or a suggestion. Would it make sense to map the SQL query back to relational algebra, do the edits there, and perhaps some analysis of internal query, and then map the result back down?
Yeah. Again, yeah. I think that's something that's worth looking into. I don't really have a great answer to that right now. I think you'd have to think of new mutations and try to kind of look at it from a different perspective. Kind of the way I've come at it is from quite a high level, just kind of seeing what is done, and having simple mutations that we can just apply that hopefully won't break too much and might have some positive impact on the performance.
I just want to add that kind of part of motivation for this work is how we can then add that mutation operator into existing GI tooling. So that's kind of why I focused on that representation, that type of mutations. So we can have a multi-objective with SQL, but also other traditional operators.
Yep. So I had a little question. You talk about multi-objective very briefly in your slides.
Yep.
How do you envision? Could you paint a vision of what multi-objective means in this space and how it would look?
Yeah, so I think kind of the two main objectives in this space would be the time for the query to execute, and then probably the size of the result that you get back, because the size of the result is going to, for one thing, impact the memory consumption of your application, and also the bandwidth that you use. I think you kind of bring those two together into one kind of objective. But I think they are quite. They do kind of work together quite well. I think a lot of the time, if you improve one, you're probably going to improve the other.
Okay.
But
I'm going to have to cut you off because you've got 5 seconds before we go offline. So thanks, everyone. I'll see you in the next talk.